This lesson we're going to talk about OR probabilities. Last two sections we talk about independence event and dependence event. Independence and dependent events we use N. But this sections we're going to talk about OR. OR probability have two different cases when the cases or events are exclusive event or not exclusive event. So when not exclusive, even the same OR, you're going to do probability of A plus probability of B minus probability of A and B. So you need to subtract the intersection of it. When it's exclusive event, then you just need to add those two probabilities. And I can show you with the graph what's the difference. So if it's exclusive event, it's not related, right? So it will be just those two different events. So when you're ordered to find probability of these two events, event A and event B, you just need to add them, right? But then when not exclusive event, so it means it's related little, right? Something like that, event A and event B. When you add these two events, you're adding, so this is event A and this is event B. When you're adding, you end up adding this N twice, right? This little area right here, overlapping area, you're adding twice. That's why you're subtracting one, right? So you will end up just adding one of each area like that. So that's what we're going to do for not exclusive event. Let's look at example 1. It says, suppose we flip a coin and roll the dice and want to know the probability of getting a head on the coin or 6 on the dice. We did the same types of problem in the independent event, but this time the word different right here. Only wording different is or, right? So that's why we're not using independent event. So we don't use multiplication because it's a or, not and, right? So then we're going to find the probability of getting head or, which that's the most important thing, or sign, you can use that, union sign, or 6 is going to be finding a probability of getting head plus probability of getting a 6. And then you can subtract probability of getting head and 6. So probability of getting a head is going to be 6 out of 12 outcomes. So here, if I write the outcomes, maybe it's easier for you to see. So if I wanted to write the outcomes, total outcomes of this event, you can have head and 1, head and 2, head and 3, all the way to 6, right? But then also you can have tail and 1, tail and 2, tail and 3, all the way to 6, right? So that's why it's the 12. So this is going to be total of 12 outcomes. So you get 12 out of getting a head is going to be this 6, right? So that's why 6 out of 12. And probability of getting a 6, you can get 6 in this case with the head, or with the tail. So it will be 2 out of 12. And then you wanted to subtract head and 6. So when you're doing this, you end up using this number right here twice. You used it twice. The first count was counting, getting ahead, but then also counted again that same number for getting a 6, right? So that's why you're going to subtract that number. That 1 out of 12. This will give you 7 out of 12 as your probabilities. Let's look at the example 2. So suppose we draw one card out of standard deck. What is the probability that we get a queen or king? So again, this is or probabilities. So probability of getting queen or king. So we're going to do probability of queen plus probability of king. Is this not exclusive event or exclusive event? This is going to be exclusive event because getting a king and queen, they're not overlapping card, right? So you just add those two events. This is going to be 4 out of 52. There is 4 queens and 4 kings out of 52. And this gives you 8 over 52. Reduce, you get 2 over 13. Let's try one more. Maybe you can try before watching this video because it's same types of problem as example 2. Basically, they're asking exactly same thing, but it said what's the probability that we get a red car? So red car or king, right? So find the probability of red or king. Is probability of red plus probability of king. And this is not exclusive event because there is red with king, right? So you need to subtract probability of red and king. So probability of red is going to be half of the card is red. So it will be 26 out of 52. King is going to be 4. But if you wanted to find the probability of red king, that's going to be only 2 out of 52, which is hearts and diamond king, right? Then this gives you 28 over 52. That's 7 over 13. What about example 4? It's a consider again that we roll 2 dice. What is the probability that the sum of 2 dice is odd or 4? So odd or 4. So this is going to be or probabilities. Or probability is adding, right? So probability of getting odds or 4. So then you wanted to get probability of getting odds plus probability of getting 4. And then if this is not exclusive event, you're going to subtract, right? Subtract what? Probability of odds and 4. But then you can kind of see odd that's going to be 4 is never happen, right? Odd have to be odd number where 4 is even, right? So that's how we know this is going to be not happen. Let me just erase it, right? This is not happening because you could tell that's going to be exclusive event, right? So then, now we're just figuring out what's the probability of odd. And remember from other section, when you're rolling 2 dice, it will be total outcome of 36, right? So it will be total outcome of 36. Getting an odd is going to be half of that. So it will be 18. And plus probability of getting a 4. So 36 out of, so let's see when can we get 4, right? This is small enough where we can write the sample space for that. So when do we get 4? When the first die is 1, second dice had to be 3. When first die is 2, second dice had to be 2 in order to make total of 4, right? And when the first die is 3, second die had to be 1. So that's just the 3 events out of 36 total. So that will be 3 out of 36. Add those two numbers, 21 out of 36 will give you 7 over 12. If you want me to give you a little review of why is the total outcome of rolling 2 dice is 36. Remember it was 1 through 1, 1, 2, all the way to 1 out of 1. The first die is 1, second die is 6. But that can happen going down too, right? 2, 1, 3, 1, 4, 1, all the way to 6, 1. All the way to 6, 6, right? So going across will be 6, going down will be 6. 6 times 6 is going to be 36. So that was your total outcomes, 36 coming from. And we went over this from the other sections when we're talking about independent event. Here is example 5. We're looking at the speeding ticket with red car or not red car again. We've seen this from previous sections. Using the same table, we wanted to see if we can get has a red car and get a speeding ticket. First, has a red car or get a speeding ticket. So we wanted to compare N and or, right? So let me write that, N and or difference using these examples. So the N, the first one, right? Trying to get probability of red and speeding ticket. So that's going to be red with speeding ticket this, right? And because it's not conditional, you're going to use the total number of the car, right? So your total number is 665 over 15. Decimal form will be 0.0226. B, getting probability of red or speeding ticket is going to be additions. So addition of probability of getting a red plus probability of getting a speed ticket minus probability of getting red and speeding ticket, right? So that's going to be probability of red is going to be 150 over the total. So it'll be 150 over 665. Speeding ticket is going to be 60 over the total. And then you're going to subtract your N, which is 15 out of 665. That's where I got this number from, right? And when you do 150 plus 60 minus 15, you get 195 over 665. Decimal form will be 0.2932. So look like or will be more higher probabilities, right? Red or speed ticket will be more higher probability than red and speeding ticket. And kind makes sense, right?